In section 11.2, we're going to find how to find probabilities by using permutations. And our learning objective here is to use a formula to calculate permutations. Our key vocabulary is going to be what is a permutation and what is n factorial. Okay, so what's important to know about permutations is a permutation is an arrangement of objects in which order is important. For example, if we take the letters A, B, and C and we care what order they're in, and we certainly do in spelling, right? So there are 6 different ways we can arrange these letters A, B, and C. So there are 6 permutations, right? So you can see there's ABC, ACB, BAC, BCA, CAB, and CBA. These are all unique and different permutations. And the way we generally find out how to do that is when we talk about making the arrangements of letters. When I select the first letters, if we take the word July, okay, the first letter could be any one of 4. So there are 4 different possible outcomes for the first letter. And then once I've selected a letter, that means there are 3 left to choose for the second letter. And then there are 2 left to choose for the third letter and 1 left for the fourth letter. So this is going to be 4 times 3, which is 12, times 2 is 24, times 1 is also 24. So there are 24 different ways to go. And if we only wanted to stop with 2 of the letters, it would just be this first part. I'm going to choose, there are 4 different possible outcomes for the first one and 3 for the second for 12. And if we look at the word mouse, 1, 2, 3, 4, 5, there's 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. Okay, so that's how we calculate out how many different permutations could there be. And in this case, we're looking specifically at rearranging letters, right? There's a more generic formula we're going to use as we go into this. And these are the formulas that we're going to work with. So these things that we've done here, so if you notice I had 4 times 3 times 2 times 1. So it's an integer times each integer less than it. So we did that both here and here. These are examples of a factorial. So this is 4 factorial, and it's written 4 with an exclamation point. And this is 5 factorial, it's written 5 with an exclamation point. The exclamation point means factorial. And this is what we were talking about here, is a digit times each of the digits below it. Okay, so this is sort of how you would talk about n factorial. This is written in sort of mathese, right? And the value, this is important to know, the value of 0 factorial is not 0, it's 1. Okay, so that's important to remember. 0 factorial is said to have a value of 1. So when we want to talk about permutations, we use the capital letter P here to denote this. And we want to look at, if we have, when we were working with the letters, we were doing n objects looked at n in sets of n, right? So we had a word with 4 letters, and we were arranging all 4 letters. That just becomes the factorial of n, okay? But in the case of the second example I did, where I was taking those 4 letters and arranging them by 2, we did 4 items taken 2 at a time. And I talked us through that it was first, there were 4 possible for the first one and then 3 possible for the second. But we can use this formula to calculate permutations. So it's the permutations of n items taken in sets of r, or set sized r, is n factorial over n minus r factorial. Okay, and when we simplify, normally what we do is we start writing out the numerator until we reach the factorial that matches the bottom factorial. It's important to know that 4 factorial divided by 2 factorial is not 2 factorial, right? It doesn't work that way. But we break the factorials into factors and then we cancel. And that's how we calculate that. So looking at this in practice, my band has written 12 songs and we're going to record 9 of them for a CD. So how many different ways, different unique CDs could we make with these 9 songs selected from 12? So this is the permutations of 12 items selected 9 at a time. That's going to be 12 factorial over 12 minus 9, the quantity 12 minus 9 factorial. So that's going to be 12 factorial over 3 factorial. And 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial, and those cancel. And if I pull out my calculator, then I can find how many different ways we can do that. So that's 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4. And there are almost 8 million ways we could go about doing this, or 80 million ways we could go about doing this. So when we look at this, we're going to be looking at the values we had, which was 79, 833, 600. So 79, 833, 600. Different ways to put this album together. Remember, that means that even if I pick the same 9 songs, because I've got to select the order of the tracks, that's why there are so many. It may seem like a crazy number, but that's how many different ways I could arrange a 9-track album out of 12 different songs that I've recorded. Okay, if we want to take a look at this, for a town parade, I'm going to ride on a float with my soccer team, and there are 12 floats in the parade. 12 floats in the parade, so now we're talking about permutations, 12 floats, right? Their order is chosen at random. Find the probability that your float is first and the float with the school chorus is second. Okay, so this is a little different. So they've already decided that soccer is first and chorus is second. So now we're not talking about 12 different floats. We've gotten rid of a bunch of them, so there's 10. Okay? Because we've already determined this is the way the beginning is going to be. Now, the number of different ways the whole parade can come out now is based on the remaining 10. So if I take 10 floats 10 at a time, that's going to be 10 factorial, right? Which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which doesn't impact anything. So that's 3,628,800. There are that many different ways for the town parade to put itself together based on the other 10 floats being rearranged after soccer and chorus. Okay, so that's working with permutations. Remember, with permutations, order matters. And we're working with this formula that the permutation of n items taken r at a time is n factorial over n minus r factorial.